Let us see in detail about control of gases contaminants or gases emission control. Depending upon the properties, there are different methods are adopted. In your syllabus, there is only 3 methods are discussing. The first one is adsorption, second one is absorption, and the third one is thermal methods. So let us see in detail about each one of the methods.
The next method of air pollution control technique, that is combustion, where the pollutant gas streams have no recovery value. So absorption and adsorption method is not feasible. So we are adopting combustion method. This waste gas contains sufficient combustible material, then incineration may be adopted to control air pollution. The applications are we can remove the odor, toxic materials, reactive materials from this polluted gas, and at the same time we can prevent the explosion hazards, and at the same time reduction of pollutant in the oxidized form. So we will get a final product, fresh product. It is normally odorless, colorless, and harmless. Sometimes the byproduct or this final product, that means high molecular weight hydrocarbons could cause smoke problems. Then another problem is inorganic materials combustion time. It makes some products like a sulfur dioxide that is harmful, and oxides of nitrogen also will produce in this inorganic materials. So we have that will also makes air pollution. So we have to remove that harmful gases from this gas streams with the help of other techniques. The another important point of this combustion method, when a pollutant is to be destroyed, the combustion must be complete. Otherwise, intermediate products will develop it. That is more toxic and more dangerous. So, for complete combustion, oxygen must come into contact with this combustible material. And the turbulence and the same time temperature also very important, and the sufficiently the time duration, long residence time should be there. So this temperature and time and the turbulence, that is so predominant role in combustion reaction, and so it is called 3Ts of combustion. And the normal ranges are temperature should be in between 375 degree to 825 degrees Celsius. And this combustion time, that residence time, that is 0.2 to 0.5 second, and the gas velocity, that should be in 4.5 to 7.5 meter per second.
There are 3 methods of combustion in common use today: direct combustion or flaring, thermal incineration, that is called afterburning or flame combustion, and last one is catalyst oxidation.
Direct combustion or flaring, it is very high temperature oxidation process, mainly used to burn waste gases. That gas contains different combustible components like volatile organic compounds, natural gas or methane, carbon monoxide or hydrogen. So we with the help of these combustible components, we are going to burn this waste gas. Mainly the refineries, petroleum production companies, and the chemical industries are adopting this type of flaring method to remove these waste gases. The working principle of this method, the waste gas are piped to a remote or usually elevated location. It's this elevated height means it's 3 to 10 to 25 meter height, then turned in an open flame. Direct combustion or flaring, It is a very high temperature oxidation process. This the waste gas we are going to burn it. This waste gas contains the combustible components like volatile organic compounds, methane or natural gases, carbon monoxide and hydrogen, etc. This is mainly used in industries like refineries, petroleum production areas and chemical industries, etc. The working principle: this waste gas is piped into a elevated location and burned in an open flame in an ambient air using a specially designed burner tip. The ingredients required for this combustion process: we require a fuel, an oxidizing agent, that is oxygen here, and a source of heat. Flares are generally categorized in two ways: by the height of the flare tip. That means that flare tip is situated, or that stack is situated in the ground level or in elevated level. Compared to the ground level, the elevated one is elevating flare is more good, because we can reduces the accidents, or we can control the dangerous conditions. At the same time, the product of combustion can be dispersed above working areas to reduce the effects of noise, heat, smoke, odors, etc. So commonly we are adopting the elevated flare type. The second one is the second type of flare. It is categorized by method of mixing at the flare tip. There are different types of flare types are there: steam assisted, air assisted, pressure assisted, and non-assisted. Let us see in detail about types of flare. The first one is steam assisted flare. In order to ensure the sufficient air and a good mix for the flame, steam is injected into the combustion zone or mixing zone. You can see the figure in the right side of this slide. Here the steam pipe is there in the left side, and right side fuel pipe is there, and the middle there is a chamber that is going to carry the polluted stream. And the top of this flare tip there is a mixing zone. With the help of this steam, the good mixing is going on this combustion zone. Mainly this steam injection flares have a single burner, and for safety reason we are using the elevated towers. Most commonly this type of flare used in chemical industries and petrochemical industries. In that way we can reduce the hazardous situations. Air assisted flare. In this, air is injected into the combustion zone to produce sufficient air and turbulence for smoke-free burning. These flares are constructed with a star-shaped or a spider-shaped burner with many small holes. Then a pressure assisted flare is there. In this, thermal incineration. The waste gas is preheated with the help of fuel-fired burner, and it is passed into combustion chamber, where the temperature of 500 to 800 degrees Celsius is maintained. Then the gas stream is kept at this elevated temperature long enough to allow complete oxidation. The time duration, that is 0.3 to 0.7 second residence time. So this 500 to 800 degrees Celsius temperature is maintained the chamber. We are going to allow this polluted gases going to pass inside this chamber. The duration is 0.3 to 0.7 seconds. Then gas stream is introduced in such geometry at a velocity that promote turbulence. So it is going to mix thoroughly with that fuel, burning fuel. The main disadvantage of this type of incinerators, it requires a little maintenance. At the same time, operating cost also there because of this fuel is using here, so we have to give the operating cost. Then a detailed figure is given in next slide. We can see that figure. This is the thermal incinerator figure. This fuel gas is there. With the help of a fuel fired burner is going to give the temperature, or this is thermal incinerator. It consists of an inlet. We are going to introduce the pollutant gas with some velocity, and there is a fuel gas burner is there. Then the outlet, we can see that there is a chamber. The chamber temperature is maintained. Temperature is 500 to 800 degrees Celsius. So the polluted gas we are going to mix in this inlet. It is going to mix with this fuel gas, and there is a flame is going to occur. It is going to pass in this chamber, and there is an exhaust also provided at the end of this incinerator. Catalytic oxidation. This type of combustion mainly used when the combustible material in waste polluted gas are too low to make direct flame. That means the energy of the pollutant gas is lesser than 3.7 megajoule per meter cube. Here the catalyst is used. Mainly platinum or palladium or their alloys are used as a catalyst. This catalysts are placed similar to the absorption bed. That means this is arranged in such a way that to provide maximum possible surface area for contact with the gas. This catalyst is coated on to suitable elements such as metal ribbons, ceramic rods, or alumina pellets. That's known as a supporting lattice. These elements are then packed into the catalyst bed. You can see the figure in next slide. In olden days, this system were effective only when the hot gases. So in that time, we are using preheaters. But now the modern days, even all the catalyst systems which works at ambient temperature have been designed, thus eliminating the necessity of preheating. So this method to remove or control the sulfur dioxide, nitrogen oxides, carbon monoxides, etc. So it is one of the efficient method. Another one is the application. It is used to purify the emissions from the industries like varnish, asphalt oxidation, printing press, etc. And it is this type of combustion technique is recommended for gases that are free of particulate matter and certainly free of metallic substances, because that which could poison the catalyst. And then this catalyst bed is cleaned periodically, that means quarterly or annually, by scrubbing with water or sometimes with acid, or by heating with high temperature, etc.